In hospital environments, specific cabling requirements are in place to ensure fire safety and protect occupants. These requirements primarily revolve around 2IO burn cabling and Plenum-rated cabling. 2IO burn cabling is indeed required in hospital environments. This requirement is typically mandated by the National Fire Protection Association 101 Life Safety Code, which is widely adopted by states and localities. 2IO burn cabling is designed with a fire-resistant coating that prevents the cable from burning for a minimum of 2 IOs when exposed to a flame. This crucial feature helps to prevent the rapid spread of fire and smoke throughout the building during a fire emergency, providing occupants with valuable time to evacuate safely. The fire-resistant properties of this cabling are essential for maintaining structural integrity and minimizing the risk of fire-related injuries or fatalities. Now let's consider Plenum-rated cabling. While NFPA 101 does not explicitly mandate Plenum-rated cabling for all areas within hospitals, its use is strongly recommended in specific areas. These areas typically include spaces with a high concentration of air conditioning ducts or other air handling equipment. Plenum-rated cabling is engineered with a special coating that prevents the cable from emitting toxic gases or smoke when exposed to heat or fire. This is particularly important in plenum spaces, which are the spaces between the suspended ceiling and the structural ceiling. These spaces often serve as pathways for air circulation throughout the building. If a fire were to occur, standard cabling in a plenum space could release harmful toxins and smoke into the air circulation system, potentially endangering occupants throughout the building. By using Plenum-rated cabling in these areas, the risk of toxic gas and smoke propagation is significantly reduced, enhancing overall fire safety. In summary, 2IO burn cabling is a mandatory requirement for all areas within hospitals to prevent the spread of fire and smoke, providing occupants with crucial time to evacuate. Additionally, while not explicitly mandated for all areas, Plenum-rated cabling is highly recommended, especially in plenum spaces and areas with high concentrations of air handling equipment, to minimize the risk of toxic gas and smoke emission during a fire. The combination of these cabling measures significantly enhances fire safety within hospital environments, protecting patients, staff, and visitors. To further clarify the distinctions between 2IO burn cabling and Plenum-rated cabling, it's essential to understand their specific design features and applications. 2IO burn cabling primarily focuses on fire resistance, meaning it is designed to withstand exposure to flames for a specified duration, in this case 2 hours. This type of cabling is typically constructed with a specialized insulation material that retards the spread of fire along the cable's length. The fire-resistant properties of 2IO burn cabling are critical for maintaining the integrity of essential circuits, such as those powering fire alarm systems, emergency lighting, and communication networks during a fire event. By ensuring that these circuits remain operational for a minimum of 2 hours, occupants have a greater chance of receiving timely warnings and safely evacuating the building. Plenum-rated cabling, on the other hand, emphasizes the reduction of toxic gas and smoke emission. This type of cabling is manufactured with materials that are specifically formulated to minimize the release of harmful substances when exposed to heat or fire. Plenum-rated cables are typically installed in plenum spaces to prevent the spread of toxic fumes throughout the building's air circulation system. The use of Plenum-rated cabling is particularly important in healthcare facilities, where patients may be more vulnerable to the effects of smoke inhalation. By minimizing the release of toxic gases and smoke, Plenum-rated cabling helps to maintain a safe and breathable environment for patients, staff, and visitors during a fire emergency. In addition to the functional distinctions between 2IO burn cabling and Plenum-rated cabling, it's also important to consider the relevant installation guidelines and best practices. When installing 2IO burn cabling, it's essential to ensure that the cable is properly supported and protected from physical damage. The cable should be installed in accordance with the manufacturer's recommendations and any applicable building codes. It's also important to avoid sharp bends or kinks in the cable, as these can compromise its fire-resistant properties. When installing Plenum-rated cabling, it's crucial to avoid damaging the cable's outer jacket. The jacket provides a protective barrier against physical damage and helps to prevent the release of toxic gases and smoke in the event of a fire. The cable should be installed in accordance with the manufacturer's recommendations and any applicable building codes. It's also important to use appropriate cable management techniques to prevent the cable from becoming tangled or overcrowded in plenum spaces. Furthermore, it's worth noting that some cabling products may combine the features of both true IO-burn cabling and plenum-rated cabling. These hybrid cables offer the benefits of both fire resistance and reduced toxic gas emission, making them an ideal choice for critical applications in healthcare facilities. When selecting cabling products for a hospital environment, it's essential to carefully consider the specific requirements of the application and consult with qualified electrical engineers or fire safety experts to ensure compliance with all applicable codes and standards. By adhering to these cabling requirements and best practices, hospitals can significantly enhance fire safety and protect the well-being of their occupant. The National Electrical Code, or NEC, also plays a role in cabling requirements within healthcare facilities, although it primarily focuses on electrical safety rather than fire resistance. However, the NEC does address issues related to the installation and grounding of cabling systems, which can indirectly contribute to fire safety. For example, the NEC specifies requirements for the proper grounding of metallic cable pathways to prevent electrical faults from igniting combustible materials. The NEC also includes provisions for the separation of power and data cables to minimize the risk of electromagnetic interference and electrical hazards. Additionally, the NEC addresses issues related to the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry without overheating. By ensuring that conductors are properly sized for the intended load, the risk of electrical fires can be significantly reduced. It's important to note that the NEC is a complex and comprehensive code that covers a wide range of electrical safety issues. Therefore, it's essential to consult with qualified electrical engineers or electricians to ensure compliance with all applicable NEC requirements when designing and installing cabling systems in healthcare facilities. In addition to the NEC, other relevant standards and guidelines may apply to cabling installations in hospitals, depending on the specific jurisdiction and application. These may include standards from organizations such as the Telecommunications Industry Association, or TIA, and the American National Standards Institute, or ANSI. TIA standards provide guidance on the performance and testing of cabling systems, while ANSI standards address issues related to safety and interoperability. By adhering to these standards and guidelines, hospitals can ensure that their cabling systems are reliable, safe, and compliant with industry best practices. Ultimately, the goal of cabling requirements in hospitals is to create a safe and reliable environment for patients, staff, and visitors. By understanding the specific requirements for 2-IO-burn cabling, plenum-rated cabling, and other relevant standards, hospitals can take proactive steps to minimize the risk of fire and ensure the well-being of their occupants. Now, let's delve into some specific scenarios where 2-IO-burn cabling and plenum-rated cabling are particularly critical in hospital environments. Firstly, consider the installation of cabling in elevator shafts. Elevator shafts are vertical pathways that can facilitate the rapid spread of fire and smoke throughout a building. Therefore, it's essential to use 2-IO-burn cabling in elevator shafts to maintain the integrity of essential circuits, such as those powering elevator controls and communication systems during a fire event. Additionally, plenum-rated cabling is recommended in elevator shafts to minimize the risk of toxic gas and smoke emission, which can endanger occupants trapped in elevators during a fire emergency. Secondly, consider the installation of cabling in operating rooms. Operating rooms are critical areas where patients undergo surgical procedures. Therefore, it's essential to use 2-IO-burn cabling in operating rooms to maintain the integrity of essential circuits, such as those powering medical equipment and life support systems during a fire event. Additionally, plenum-rated cabling is recommended in operating rooms to minimize the risk of toxic gas and smoke emission, which can compromise the health and safety of patients and medical personnel. Thirdly, consider the installation of cabling in intensive care units, or ICUs. ICU are areas where critically ill patients receive specialized medical care. Therefore, it's essential to use 2i or burn cabling in ICU to maintain the integrity of essential circuits such as those powering patient monitoring equipment and life support systems during a fire event. Additionally, Plenum-rated cabling is recommended in ICU to minimize the risk of toxic gas and smoke emission, which can exacerbate the condition of vulnerable patients. Fourthly, consider the installation of cabling in data centers. Data centers are areas where critical IT infrastructure is housed. Therefore, it's essential to use 2i or burn cabling in data centers to maintain the integrity of essential circuits, such as those powering servers and network equipment during a fire event. Additionally, Plenum-rated cabling is recommended in data centers to minimize the risk of toxic gas and smoke emission, which can damage sensitive electronic equipment and disrupt critical IT services. These are just a few examples of the many scenarios where 2i or burn cabling and Plenum-rated cabling are particularly critical in hospital environments. By carefully considering the specific requirements of each application and adhering to all applicable codes and standards, hospitals can ensure that their cabling systems are safe, reliable, and compliant with industry best practices. Furthermore, it's important to emphasize the role of regular inspections and maintenance in ensuring the continued effectiveness of cabling systems in hospitals. Regular inspections should be conducted to identify any signs of damage, wear, or deterioration in the cabling infrastructure. Any damaged or deteriorated cable should be promptly repaired or replaced to prevent potential hazards. Additionally, regular maintenance should be performed to ensure that cable pathways are clear and unobstructed. Cables should be properly supported and secured to prevent them from becoming tangled or damaged. Cable management practices should be reviewed and updated as needed to ensure that cabling systems remain organized and efficient. In addition to visual inspections, electrical testing should be performed periodically to verify the integrity of cabling circuits. Testing should be conducted by qualified electrical technicians using appropriate testing equipment. Test results should be documented and reviewed to identify any potential problems. By implementing a comprehensive inspection and maintenance program, hospitals can ensure that their cabling systems remain safe, reliable, and compliant with all applicable codes and standards. The frequency of inspections and maintenance should be determined based on factors such as the age of the cabling system, the environmental conditions, and the criticality of the application. Hospitals should consult with qualified electrical engineers or fire safety experts to develop a customized inspection and maintenance program that meets their specific needs. In conclusion, cabling requirements in hospitals are designed to protect patients, staff, and visitors from the hazards of fire. By understanding the specific requirements for 2i or burn cabling, Plenum-rated cabling, and other relevant standards, hospitals can take proactive steps to minimize the risk of fire and ensure the well-being of their occupants. Regular inspections and maintenance are essential for ensuring the continued effectiveness of cabling systems. By implementing a comprehensive inspection and maintenance program, hospitals can ensure that their cabling systems remain safe, reliable, and compliant with all applicable codes and standards. Remember, fire safety is a critical aspect of healthcare facility management, and cabling systems play a vital role in protecting lives and property. By investing in appropriate cabling technologies and implementing sound maintenance practices, hospitals can create a safe and secure environment for all.